Hello.
Yes, sir. We are live.
Yes.
Hello.
Yes. Yes, Rahul.
Hello, this is Michael Zimmerman with FlowSurf.
Hi. Hi. Good evening for you right now.
Hello.
Yeah, okay, it's Ben.
Hello, Mr. Moy. How are you?
Good. Hey, Michael, how are you?
Good, how are you doing?
It's been a while.
Good.
Rahul, can you share your screen?
Yes, I will share. Samkha, can you give me that access?
Yes, sir. Your access is granted.
Okay. I'm able to.
Good afternoon and good evening to all the panelists. And I'm really happy that everybody has joined in. We will be starting in another, I think, 5 minutes. So kindly hold on. Thank you for joining. Good afternoon, everyone. Thank you for joining in. And we have some prestige guests today who have joined in from various parts of the world. It gives us immense pleasure uh, to host such a big panel we have today for the discussion on AM application in the power sector. And so today's webinar is just in addition to what we have been doing for past couple of months. So it is objectifies knowledge sharing combined with an effort to engage our viewership about the technology, about how the AM has been adopted in various segments. So in the previous uh, innovators at the home, we discussed the complete technology, we discussed all the application, we discussed the tools and rules, limitations, and we discussed the future of additive manufacturing. And from past 1 week, we have been discussing on conformer cooling, which we did on last Saturday. It was greatly taken by the tool makers around the world, and we had a great audience. Since then, we have been getting a very fine feedback. We have been hearing a lot about what was discussed during the webinar and what was the feedback from the panelists itself. Then after that, we discussed a lot on the topology optimization in our previous webinar, which was hosted on 26th May. And there we again discussed on the implementation of the technology, and we discussed how deeply design is valid for AM and how deeply we should understand what are the key benefits and the key way forward for the technology itself. So today we are going to conduct the webinar on AM's application in the power sector. So this is an ongoing debate of adoption of technologies like additive manufacturing in the power sector. As you can see, the oil prices are dropping down, the cash flow is becoming a challenge for most of the big oil and gas and the power sector. And current scenario of COVID-19 is one of the biggest challenge the globe is facing currently. And so if additive can be a savior for most of the customers to make them come back to their work, and they can go forward in catering their customers. So we decided of conducting a webinar. So today with me, Mr. Rahul Pise, who has joined us. He will be conducting the presentation side, and I will be hosting our group panelists. So today we have, I think it might be one of the most proudest moment that we were able to collect from the complete chain of people for implementation of a technology. So we have Mr. Benjamin Moy, who is the head of Siemens, Vice President of Advanced Manufacturing and Digital Industries. He's placed in Singapore. Hello, Mr. Benjamin. Today, again, we have Mr. Shastri, who is the principal specialist for Global AM from DNVGL, which is a qualitative and certification agency for processes. Also, we have from Extrude Hone, Tommaso Beccuti and Chandan Shamprasad, who are from, who will be discussing about the post-processing side of the requirement of implementing AM technology. Then we have Mr. Michael Zimmerman and Kaushik Ashokan from Flowserve, which again is one of the OEM and one of the key ingredient of a power plant sector. Also, we have Mr. Manoj Kabre, who is the Vice President of Sales, Vice President of Sales and Marketing at Indomim. So with Manoj sir, we share a different level of engagement, that they are our customers also and they are our supplier. So we'll be discussing from a MIM perspective what kind of trends the additive is following as compared to the MIM, and where we are currently, because we have learned a lot during the COVID-19 how to read trends. People have been following all the trend curves everywhere. So So, Rahul, can you take up the presentation from here? And then I can join you back.
Hi, Ankit. Thanks. We had one slide about the recap of the last webinar, as Ankit was mentioning how we had been generating the uh, interest as well as staying connected with our client base. So this is the webinar we did this week on Tuesday. So this was about the how we can engineer efficiency again with the new enabling tools. So the focus was mostly about the design for additive manufacturing. So how we can take care of the rules and tools available, and with those at our disposal, how we can minimize the defects with the design for additive manufacturing, and how we can validate. So that was discussed earlier. So let's get back to the uh, core topic. So this was the poll we did. So similarly, we want to do poll again for this session. Sankha, can you post that poll so that we understand the audience and all their interest and where they are coming from, so that we uh, have our panel discussions and the session catering to the overall perspective, where our audience is coming from, where we are situated as a service bureau, how the uh, AM, OEM manufacturers of the power sector, as well as AM machine manufacturers, post-processing manufacturers, their interest, raw supply chain for the powder, those sort of players as well, get the perspective of our audience, and how we can generate the momentum. That's the key core agenda uh, for staying connected as a community who is invested in this evolving technology, and how we can work together. So that's the uh, core agenda for the webinar. So poll, please, Sankha.
I have just launched the poll. I would request everyone to kindly give in your inputs. It will appear on your screen right now. Uh, Kindly give your answers. Sir, you can continue. The poll is running.
Okay, thank you. So a couple of ground rules and some requests for the audience as well as panelists as well. So we are having this in a public forum, and our audience is from diverse background. So we are not going to go into a specific projects as such in this webinar. So we are highlighting and bringing the limelight or focus on few of the areas which are not exposed and very crucial for serious adoption and ensuring the quality delivery. There has been a lot of media attention. There are marketing campaigns from the 3D printer manufacturers, service bureaus. That sort of campaigning is going on quite extensively. But we want to address each industry segment needs and how we can influence and cater to those needs. That is the mindset we are keeping. So please refrain from asking any detailed project related query or specifics like CAD models or uh, material specifications or what to expect and where it is implemented, what scenario or problem it is solving. So those sort of specifics we are not going to discuss. And sometimes these type of know-how are the competitive advantage of an individual who had worked hard on those projects. So we don't want to reveal that. So with those ground rules, let me begin. So today we are going to discuss additive manufacturing applications in the power sector. So power sector being quite a big umbrella. Under that, we have a lot of oil and gas extraction and petrochemical processing industry. Then in order to process the fluids, or either it can be a gas or petrochemical crude oils. So those have to be processed, and those have to be pumped, delivered at the targeted locations efficiently with the control and all. So those fluid flow control manufacturers as well, those sort of devices and processing plants. Then how AM can as well benefit the power plant industry with the where actual power production goes on in a gas supplied turbines or the steam turbines, then which are the relevant alloys processing methodologies and the post-processing requirement, how that ecosystem looks like, and what is the economics revolving around it. There are definitely hurdles, and those hurdles are to be overcome as a community. That's why we are connecting and having this type of a session, listen to the best in class players, and how this industry is trending and evolving, what we can learn from them and re-implement the methodology and principles that can be learned and reapplied. And that's the purpose of today's webinar. Uh, Ultimately, the panel discussion is something everybody is hoping for, to listen to the expert advice and take on the evolution of this technology and how they had been contributing or extracting value out of it. So that's the core agenda. The PPT is going to be just 15 minutes. I'm going to just set out the playing field or the groundwork, and Ankit will take over again to have a detailed discussions and question and answers with panelists. So you can post your questions and answers as well. So those questions you can post it in Q&A forum. So there is a text link for that. So you can put your questions in text, and we can choose some of the relevant question to be answered live. And meanwhile the discussion is going on, our team members, myself, Ashish from our sales and application department, he's going to answer some of the queries as well. And if you have specific question to the panelists as well, you can list the we will ask those sort of questions to the panelists after screening those questions. So we have certain predefined questions that Ankit is going to ask first, and then the forum is open for Q&A and interaction between panelists. Okay, so let's get started. So the first one is the oil and gas industry. So most of the equipments are being used in a sea and groundwater type of scenarios, where it has to be corrosion resistance as well as foolproof to that sort of environment. So the strength and durability and prolonged service life is also expected. So for the purpose of showcasing some of the photos and case studies, we had chosen some of the typical components that we had produced, and some of the components you can see over here: impellers, open and closed type, or fluid control, hydraulic manifolds, or inducers, those sort of components. And the material that we can use for that is either SS316L, that's the stainless steel grade, or titanium alloys. And on top of that, I would like to address on the go that although there are few grades that are easily applicable and adopted by the industry, there is still some amount of work to be done. Certain grades of steel that industry is very comfortable and they had been practicing for so many decades or even centuries, they are comfortable using those grades, and there is a effort needed to develop those sort of materials on additive manufacturing platform too. So again, in case of processing plants, the similar requirements, acids or bases, but few examples of that again I am sharing. So in this case, the static mixers are unique. So if two materials or fluids had to be mixed in a flow, then these type of features are very difficult to make, and only additive manufacturing is allowing it to be done very easily without the severe amount of pressure loss. Then third one is the fluid flow and control. Again, the similar sort of components, so centrifugal pump impellers or blisk or open impellers, solenoid control valves, these are again being developed. So in this case as well, the complex fluid flow pattern, so a lot of undercuts and complex geometry which is a curved vein type of geometries are common, and surface treatment for service life is also crucial. So now coming to the topic of gas and steam turbines, in those cases, the highest amount of service temperature you can imagine are being experienced by these alloys. So typically more than 1000 degrees or 800 to 1000 degrees is the in the Celsius is the service duty cycle of in turbine certain zones where exactly after the burning hot gas passes over the turbine rotor blades as well as the stator vanes, and the flame tube itself is also at quite drastically higher temperatures. So the alloys being used in those scenarios are mostly nickel alloys. Inconel 625 and Inconel 718 are being used in these scenarios. But on top of that, there are additional grades of nickel alloys are in demand. So CM247 is slowly graduating and transitioning to be adopted in AM. Similarly, there are few more nickel alloys. Those are super alloys being used in the gas turbine and steam turbine type of industries, which need to be qualified for additive manufacturing. And on the compressor side as well, so the lightweight titanium or titanium aluminide type of alloys are used for the blades or the stators. So those sort of high strength to weight ratio alloy are crucial at the compressor side as well, because ultimately compressor is a kind of a secondary function which is not generating power but compressing the air, bringing it to the service temperature so that the fuel burns with the good efficiency. So it is a kind of a driven wheel, you can say. The driver is the turbine, and it has to uh, run robustly, and the lighter the weight of the compressor side is better, so that the inertia at the initial stages and during the operation as well, that inertia loss is minimal for the compressor side. So that's how uh, additive manufacturing is being looked at for gas turbines, and gas turbines are being used in aviation industry, and we are riding on that curve of learning. That's a beneficial for this power sector, because already the due diligence and service duty cycle and life cycle had been tested rigorously for the aircrafts, and GE being one of the leader, then Rolls-Royce, Collins Aerospace, all these type of companies had looked at it thoroughly and had been qualifying the components. So AM can ride on that learning and refer to those data. So these are the typical materials that we recommend to our customers. So in metals, we have several alloys. In steel, the ferrous alloys are MS1, tool steel in H13. Then in stainless grade, we have Corex CX, and that's a corrosion resistance, a good quality alloy. Similarly, SS316L, SS17-4PH, and there are a few more under development as well in stainless steel grades. So the martensites being the, so these covers the austenites, but martensitic alloys are also under investigation and being developed. Nickel alloy already mentioned. Aluminum grades are there. Titanium also, and cobalt chrome. Copper is being developed as well. In polymers, there are few relevant polymers that this segment of industry can consider to use. So that's the prime cast for casting bigger size components. So that is something people can consider as a lost wax method for investment casting. The pattern can be 3D printed using prime cast polystyrene, and certain flame retardant as well as the glass field type of nylon components can be serving at the field duty as well. So let me move on to the news and highlights that happened in the industry. So G had been a first mover. So they formed the additive division and acquired two big companies in additive manufacturing. So those are mostly machine makers like Concept Laser and Arcam EBM. And they acquired some aero related businesses as well. And those were the early adopters of the technology, and G aggregated and serving the variety of interest in aviation, power sector, healthcare, and all. So similarly, Siemens is another big player, and we have in panelists one of the senior ranking executive from that uh, organization. So this corporation had been huge player in the uh, domain of power sector, and they have installations of gas turbine, steam turbine, and allied subsidiary operations across the world. And they acquired Material Solutions group, and that is playing in additive manufacturing. And Siemens had been a good service provider of the software solutions as well. So they have the Unigraphics NX modules and Team Center product lifecycle management solutions. So under that umbrella, they are bringing the new acquisition of Atlas 3D, and with that, additive manufacturing is going to be catered as well. Just like the conventional designs that you can make using their workbenches for casting, forging. Similarly, for additive manufacturing, 3D printing, whichever process that you want to pick up, based on that, you can program and design at catering to that manufacturing life cycle. So that is something amazing as a aggregation happening and integration happening in the industry. So some of the use cases. So since we don't want to plagiarism is also quite prevalent. So first of all, I shared all the examples in previous PPTs. Those were produced by us and in the specific alloy grades and in specific use cases. So these are some of the photographs I picked up from the Google feed. And this fuel delivery nozzle is one of the example from Siemens itself. The aluminide blades of a compressor are G example. So I need to give proper attribution. And these are the few of the turbine blades for one of the actual use cases where 3D printed that sort of blades were being assembled by one of the company, and the demand is on the bigger size components as well. So the 3D printing with powder bed fusion is maturing. We have those sort of installation, and the previous examples were from that. But the industry is quickly asking for more. They are hungry for even bigger size components and all. So we will ask those sort of questions to the OEMs themselves. So supply chain is one topic that I wanted to bring attention. So I will be taking another 5 minutes, and then we can move on to the panel discussion. So supply chain had been very distributed and fixed type of automation. So you can see from the ores or the scrap metal smelting happens, and the billeting type of feed, raw feed, is again has to be remelted, sand casted, investment casted, or for forging has to occur. Or those billets can be directly CNC fed to the CNC milling machines as a block machining, and a lot of wastage occurs. So since you are melting and remelting, or you are making a tiny piece of component from a very huge block of component, there had been a lot of wastages, as well as the slow pace of transition. So disruption of supply chains is something that Ankit spoke at the beginning. And in case of COVID example, we saw that a lot of players wanted to make certain healthcare equipment ad hoc, and they were able to manage because of the advent of 3D printing. They had those sort of machines at their disposal, and it was in-house. They can fabricate and produce those sort of components. So the supply chain of additive manufacturing is directly from smelting. You can go for that specific composition of alloy to gas atomize. Those powders are compact and can be shipped around the globe, and the manufacturing can happen distributed. So one example is direct metal laser sintering. That's the powder bed fusion. So that's what something I am showing here. So in a summary, the conventional had been very centralized, capital intensive, and fixed automation type. And you can expect huge volume of production out of that at cheaper rate to make a lot of variety of components. So limited flexibility to handle the changing needs. And there had been a lot of handshake necessary. So you need to work with a lot of supply chain partners in conventional manner. But in case of additive, it can be distributed, low capital intensive, flexible enough, and it can handle low volume, high mix. And tremendous flexibility is in fact the uh, tremendous attribute of this additive manufacturing technology. So with that, you can handle the changing needs quite efficiently. So conventionally, the production immediately cannot be replaced. So since those are fixed automation, the capital intensive heavy lifting had already been done. So gradually this technology is filling up the shoe where it can efficiently play a role. That's the maintenance, repairs and overhauls. So in those cases, physical inventory had been a common norm. So I think one of the case study example you can take is the uh, agricultural industry. In that sort of industry, there had been a lot of huge warehouses built by uh, big players, and they have almost uh, around 3 or 4 football field type of warehouses to keep the components, and the equipments are continuously evolving. So if uh, 20 years old equipment gets faulty, they had to run around and pick up. So organized inventory is something that people try to look for, but the practical reality on the workshops in MRO type of workshops, and the shelves are always messy. So there is no identification. It becomes tedious as well to operate. So those are dead cost, dead capital in inventory. But additive manufacturing is uniquely offering the digital inventory and cloud storage. So you can keep you have to get the cheaper rental want to showcase over here and how that was turned around to deliver the service as well as the quality that demanded by the customer or the end users. That is something as a digital twin. That record is quite crucial. So we had been investing in our centralized server type of environment where we keep the records of overall process life cycle. And thanks to our efforts with the certification for aerospace industry, they dictate that records had to be maintained. And because of that, we have this infrastructure in place for AS9100D certification, and that can be quite beneficial for the industry. So they can qualify the components with us and distributedly manufacture the parts if it is necessary. So we can do the handshake of sharing the digital twins once the parts are qualified and scale it up if you want to build on-demand inventory of small scale in distributed fashion. So again, going back to the quality control, as I briefly mentioned, so the certification that we secured already is ISO 9001. That's the basic for auto sector, FMCG, white goods to work in India. And its qualification is sufficient to deliver services in the segments of industry. For aerospace specifically, the stringent quality requirements and the level of detail is essential. So that's why we acquired this AS9100D. Similarly, we have with us today DNVGL's representative, Mr. Shastri sir. So there had been efforts and spearheading by DNVGL has happened to adopt these type of components in oil and gas and offshore industry and power sector. So he will briefly explain about that later. So yeah, that's all for me. I think we have a second poll before we go into the panel discussions and introduce our uh, panelists one by one. Yeah, Sankha, second poll, please. And over to you, Ankit.
Yes,
Thank you.
so I'll be launching the final poll for today. I would request everyone to please give your inputs. Yes, the poll is running. I would request everyone to please give your answers. Meanwhile, Ankit sir, you can take over. Thank you.
Yes. Rahul, can you move over?
Yes.
Yes. So today I would like to introduce Mr. Benjamin Moy, who is one of the panelists for the talk today. He's joined us from Singapore cements, and he's a great friend, and he's a great evangelist of the technology in that region. And he has been working with Additive for quite some time now, and he is in the organization where I think it is one of the highest invested organization in the world right now for Additive. And that's how we see the region where we are, like the Southeast Asia and the SAARC region, where most of the energy requirement is coming in, and lot of people are looking at Additive as a solution. So today he'll be joining us. He'll be talking about additive manufacturing in the power sector. Benjamin, do you want to introduce yourself?
Thanks, Ankit. Thanks for having me here today. Hello, everyone. Yeah, I've been following additive manufacturing for quite a while, and as Siemens, I think we've been on this journey for quite a while, and I hope to share as much as I can in this space and see the future for.
Hello, Mr. Moy.
Can you hear me?
Yes, please.
Yeah, so thanks for having me. I think we're very privileged to be here. Ankit and I go back quite a while, a long way, and we've been talking about additive manufacturing for quite some time. And I'll share as much as we can. Siemens has been leading, or has been we're looking at additive for over 8 years already. We'll talk about our progress and share as much as we can on what we see the future for additive might be.
Sure, Mr. Moy. Rahul? Good evening, Mr. Dr. Shastri. It is again like an immense this pleasure for introducing a personality like Mr. Shastri, Dr. Shastri, and he has been working with DNVGL for the certification for oil and gas, maritime, and manufacturing sector for additive manufacturing. He's leading the Additive Manufacturing Technology Center of Excellence in Singapore, and he's a well-known contributor for the technology and implementation within the sector itself. Dr. Shastri, do you want to introduce yourself?
Yeah, thank you for having me, and yeah, also I welcome all those who are participating and also in the panels. Yes, yeah, additive manufacturing is close to my heart, partly because I've been working with this for almost more than 20 years now. So I started this journey almost in 1999 around in Belgium as a scientist there. So we were working in the first batches of printers, technology development, etc. But later I moved to Canada and started developing cold spray technology for power sector. For example, this nuclear power sector, and also for defense applications. But later I moved almost 14 years ago to Norway, and as a material specialist, I have been overseeing all our approvals of manufacturers. Means we have more than 2,000 manufacturers around the world. So that is combining my both traditional, conventional manufacturing experience and also I have developed a lot of schemes for certification of parts both in maritime and oil and gas, and these are very well deep into very high technically demanding projects around the world. So yeah, so then for a few years we have been asked by a lot of suppliers around the world how AAM can be adopted in maritime and oil and gas. For last 5 years, I've been intensely engaged, and 3 years ago I moved to Singapore, and with the help of Singapore government, we had set up the center. So later I will share my knowledge. Thank you.
Thank you so much, Rahul. So also we have Michael Zimmerman and Kaushik Ashokan from Flowserve. Flowserve is a American company which looks after components and valves for oil and gas power, chemical, and water resource sector. And Michael Zimmerman is the manager of R&D at Flowserve Singapore, and Mr. Kaushik is a senior engineer at Flowserve, and they are our proud customers. And we have been working for almost 1 year, and it has been a great journey with the Flowserve team. We have been also involved with the Indian counterparts, and it has been a great understanding with them for their customers' requirement and how we should serve them better. So Michael and Kaushik, can you help me with more details about yourself?
Yes, thank you very much, and I hope everyone can hear me. Let me know, guys. Yeah, very pleased to be a part of this conversation and looking forward to discussing some more details here. Flowserve is, as you mentioned, an OEM in many different industries, serving fluid control systems over pumps, valves, and seals. And we've been looking through the additive manufacturing journey over the last several years, looking back through indirect methods of manufacturing for castings, and obviously much more recently through more direct methods through metal printing. And we're really excited to be part of this discussion and have been making some great headway over the last couple of years through our development here in Singapore and our center of excellence we have here to support our global business efforts around additive manufacturing. So I'm excited to be here and looking forward to discuss with everyone more. Yeah.
Thank you. Thank you, Michael. Thank you for joining. Hi, Kaushik. Thank you for joining today.
Thanks, Raghu. Yeah.
Rahul, can you move? So again, we have Mr. Manoj Kabre from Indo-MIM. As I have told you in the very beginning, with Indo-MIM, we share not just a supplier kind of relationship, but we are their customers also. So Indo-MIM is the first company in India to be able to manufacture an indigenized powder for additive manufacturing. And they have been the forerunners in the MIM technology, that is in metal injection molding. They are the largest in the world right now. And Mr. Manoj is the Vice President of Sales and Marketing for Indo-MIM for the Asia region and the European region. And he's a very social kind of a person, and he's been involved in training a company like Objectify. He has been mentoring so many again startups. He has been involved in different kind of social organizations too. So Manoj sir, how are you? Hello, Manoj sir.
Sorry, can you hear me well?
Yes, Manoj
Yeah,
sir.
yeah. I'm fine, thank you, Ankit.
So sir, do you want to introduce yourself?
Yeah, I think you did major point of that, but hello everyone. Hello to the panelists and a big shout out to all the 162 participants that I see here. And compliments to you, Ankit, and your entire team led by Mr. Pise. I think you all have been doing a wonderful job. I see here. This is the first webinar I'm attending of yours, but looks like you have been doing a world-class job. Similar to the activities that you do on your machines.
Thank you so much.
So, well, we are into the space as rightly mentioned by Ankit, majorly metal injection molding. That's been our core technology that we have been practicing since 1997. And as Ankit said, we are the world's largest company in this space and have homegrown this technology, although we started as a collaboration, more because of the people at our end, and more also because of the support from our customers. So we have about 92% of our customers who are outside India. And we have been normally involved right from the concept stage of every development. And we extended the same belief and the same system to the powder development that we started a few years back, where we mainly focused on additive manufacturing. And with the support of customers like Objectify, what we have been doing is we have been trying to develop new powders which are required, especially by the oil and gas and aerospace sectors. And we try to bring these powders as per the requirements, tailor-made to the customer requirements, so that you all can really lead the additive journey the way you have envisaged. So that's all from me at the moment.
Thank you, Manoj sir. I'll come back to you after introducing everyone.
Yeah.
Rahul, can you move? So again, we have so what we try to do, we try to engage the certification agency, we try to engage the powder manufacturing, we try to engage the end customers who are forerunning for their users. And today also we have Extrude Hone, which is a metal finishing, like the post processing of the final product, and they are very experienced with the additive manufacturing technology. So we have Tommaso Vecchiuti and we have Mr. Chandan Shamprasad. So Tommaso is joining us from Turin, as I guess, and he is the business unit additive manufacturing developer at Extrude Hone, and he has been working with various clients from the aerospace to the MRO to the oil and gas customers. And it is a great pleasure to host you and get your perspective from post-processing side. So Mr. Tommaso, would you want to put in some words for us? Mr. Tommaso. Hello. So I think there's some technical error. So then we'll start with some question rounds. So Rahul, can you move further? Mr. Tommaso, you.
Yeah, can you hear me?
Yes, loud and
okay,
clear.
Sorry, I was speaking on mute. Thanks a lot for inviting me. It's a pleasure being here, and I'm looking forward for useful discussion between us. Extrude Hone is a worldwide leading provider of surface finishing technologies and deburring technologies. Since a few years, we started up a business unit dedicated to the specific need of the additive improvement. As you mentioned, we have actually quite a lot of experience also working with the oil and gas industry, which has been one of the early adopters of additive. And well, I'm pleased to be here. Chandan, if you want to add anything, otherwise, again, looking forward for the discussion.
Yes, Mr. Chandan, I'm not able to find him in the list today. So what we'll do is like we'll go forward with the discussion. If Mr. Chandan will be joining back again, we can get introduction.
Okay, no problem.
Okay. So we will be starting with the panel discussion. So my first question will be with an organization who has invested more than, I think, almost $300 million in the technology of additive manufacturing and implementing with the end customers. And so my question is with Mr. Benjamin Moy. So I just wanted to ask, Mr. Moy, companies like Siemens and others like GE or some other, can you tell me like what kind of a thought process goes when you start identifying a technology like additive for your supply chain? Because you are such a big organization that implementing something new takes a lot of time, a lot of effort, a lot of people's engagement in the project. So can you tell me about your journey?
Sure.
About the organization's journey?
Sure. So generally Siemens is very cutting edge. We are a very innovative company, and I would say 60% of us are actually more engineers within the organization. So we have a huge pool of engineers within our teams. And usually the ideas come up from the divisions itself, from the product lines. So the ideas sprout out from the bottom up, and then our corporate R&D teams take over and try to spread the good stuff to all the other divisions. So specific to additive, I think we started our journey about, I would say, like I mentioned, 8 years ago. And today we put on 3 different hats Not many people know this. One, we put on a software hat where we develop NXCAD and simulation and generative designs to support the design portion of additive manufacturing to make it simplified and easier for customers to design for AM. We also put on the hat of an OEM in oil and gas, where we also try to optimize our designs using 3D printing so that it's lighter and more functional and easier to service. We have a third hat, which you have mentioned earlier on, where we recently acquired Material Solutions as a services bureau. So we function in 3 different roles, and I'm proud to say that Material Solutions, we recently opened up a second branch. The original branch is based in UK, and now we have one based in the US. So we're trying to reach out to as many AM interested customers to support them in their growth and adoption for AM.
So how do you see a decision-making trend for an organization like Siemens on selecting the right component, selecting the right process, selecting a right quantity or something like what is the decision-making Siemens do for their implementation?
Yeah, so we have a very clear strategy in terms of additive manufacturing, especially in oil and gas. Our energy team has a very strong focus on converting at least 20% of our gas turbine designs to using additive. At the moment, we're working towards that 200 different components sort of target, specifically for the gas turbines. This has sort of propagated to our compressors, our steam turbines as well. So I think there is an inherent strategy on a product level basis rather than component basis. But now on site, production manufacturing houses catered for just the oil and gas division building part.
Yeah. So my other question will be with Shastri sir. So sir, how do you see additive becoming for certification agency like DNV? How do you see that being a challenge for additive? Because what we have as a service bureau, what we have also realized, like every machine is unique, every material is unique, every batch is unique. How do you standardize things? How do you certify things? How do you control quality? How do you give that as an idea to a user?
Okay, thank you. I think so. This is a very interesting question. Actually, this uncertainty, as you have explained, there are so many variables. This additive manufacturing sometimes looks like an ocean itself with so many varieties of things, and each one you dig, there are hundreds and thousands of parameters. And how can we certify? The certification is endorsement of the quality that defines or that endorses the consistency, repeatability, and confidence in the process. So it's quite a challenging task. So for example, if I bring an analogy, like how the 3 phases of a matter, like a solid, liquid, and gaseous stage. If solid is the most consolidated knowledge, and liquid is not very much, you don't understand too much. So for conventional manufacturing or conventional parts and products, you have a 70-20-10 kind of thing. So 70% of knowledge everybody knows, it's quite crystallized. You have standards, you have procedures, everything. 20% is always advancing, 10% is so this is exactly opposite. 10% of AM knowledge is only solidified as standards or procedures or whatever developed. So a large part, you can say 70% of the part of additive manufacturing is in that sense is the liquid or gaseous stage, meaning it is not crystallized knowledge. So what we are using is we are using the reference knowledge from our conventional manufacturing, and we know that if you follow certain procedures and follow a certain disciplined way of quality control procedures, you would end up with a certainly a consistent, reliable, and a product that you can have confidence. So we are using that reference, and we are trying to continuously filter out what is the best knowledge that you can today certify, and what you should do to solidify the knowledge. Like running R&D projects is one of the biggest thing we are doing. We are at any time more than 10 joint industry projects with maybe 60 to 70 companies around the world. That is feeding us. So that is the strength of our certification. The data we collect from that is feeding back. Yeah, I hope.
So how do you exchange notes with organization like ASTM or AMS, which are also doing on the aerospace side? There are certain agencies for the medical side who are doing. So do you exchange notes for additive manufacturing with these agencies, or is it like everybody is working in their own areas?
Yeah, so again, this is very, very, very interesting. Probably several years ago, maybe we were all developing our things on our own. But today, we all see that we are all, standard bodies like us, which we are very specifically working for oil and gas, maritime, etc., or energy sectors, whereas ASTM is writing standards that would support the standards we would be developing. For example, if we say you have to do a tensile test at, that should be, tensile specimen should be 10 millimeters below the surface. This is where we identify as the weakest region. ASTM actually develops something, how to do this test. So there is a complementary role. So that is why we are working. For example, if you ask me, I am on several ISO ASTM committees. And also, for example, I am also working with the Singapore National Standards Committee, even Singapore Military Additive Manufacturing Standards Committee, because all these participations bring us, they enrich from our knowledge, and we get enriched from their knowledge. So there is a quite fluid, what you can say, we have a very good interaction with these agencies, and this is how we are calibrating.
Oh, great, great. Michael, I just have a small this thing, because we have been working for almost a year, and what we have understood with an organization like FlowServe is like we have to still find some certain like level of supply chain answers for your end customers with additive manufacturing. How do you see that moving forward as a technology for your end customers?
Thank you. Yeah, that's a very interesting question. So as FlowServe as an OEM, we serve many different markets, many different customers that have a very broad range of products, right? So where we are looking at to leverage AM is across a very broad spectrum, right? So we're looking at ways that we can, as an OEM, control that in a certain extent. And that some people may think that that could be done by bringing in machines in-house and really operating them at in-house and things like that. But where we're looking at ways to accomplish that for our global, perspective of customers is to really expand our supply chain and work with suppliers like yourself and Objectify to really produce these parts really closer to the site and where our customers are really going to need those end products. So that's really the first thing out of three that I think that are really important. And in part of that, we want to be able to produce those parts closer to the site so we can reduce shipping and transportation costs and provide the quality components closer there. And on the second point, I think that we want to really look at a more on-demand production model where we want to look at developing our digital inventory so that we don't have to require conventional tools. FlowServe is a 200-year-old company. We're really focused on castings and things like that. And some of our parts, haven't been out of service for 50 years. So sometimes customers have a part that they need that hasn't been out of service. There's no more pattern to make a casting, and we need to really produce a 3D printing part on a quick time frame to meet that urgent need. So that's one of the second point there that I'm looking at.
Mhm.
And again, of course, where we really see additive manufacturing bringing value to our customers is, of course, with the time to market. Okay, and sometimes there's a trade-off with that, with cost, but we're working with oil and gas customers and power customers where if there's a downtime situation and they need to have
Mhm.
now, they need it now, and you cannot wait to make tooling for casting. You cannot wait for the long lead times that you sometimes have with certain casting suppliers. So we want to really develop our supply chain to be adaptable and nimble, so that we can send them a digital file and make a part right away, so that we can then have it really close to the customer and they can install it in their pumps or their valves or their seal right away.
Mhm.
So there's many different assets, or many different aspects, I would say, where we can really disrupt the supply chain, and we're starting to do that, and we're really looking forward to expanding on that in the near future.
Sure. So what are the key questions from your customer when they're, because what I have realized is as I also go to meet my customers a lot, and the skepticism is quite high for additive manufacturing. Will it stand? Will the material match up? Will the geometry will be okay? Will the surface finish? So what kind of questions do you face when you propose from an investment casting to additive manufacturing? What kind of questions are you facing from your end customers?
Sure. That's always for us. We're really trying to figure out how to really standardize our answer around that. But for now, it's sometimes complicated, and what we've kind of broken it down to is how we can supply an offering based on part size, material choice, and then how we want to post-process that. So around part size with additive manufacturing, you have to understand from our perspective, again, we really produce a very broad spectrum of parts, from parts that are maybe, I don't know, 2 meters in diameter to parts that are very complex in geometry that can fit in your hand. Again, so sometimes that there are many different ways we can solve that with additive manufacturing. And I will say that the first part we're seeing here with additive manufacturing is that we want to be able to expand the part size. A lot of our parts, are generally simple from a geometry standpoint, but they're larger than what can fit into a powder bed fusion type machine. So that's one challenge we have right now. We need to be able to expand the size and still get the same quality of the part without having to do too much post-processing. From a second standpoint there, material choices. So we're expanding. I know that we're expanding material opportunities within AM, and there's being standards being developed through STM and other bodies, and we're working with DNVGL and of course Dr. Sastry here to independently verify some of those materials, but we need to expand that, because again, when we're producing parts for many different industries, we're looking at corrosion characteristics, we're looking at different wide ranges of temperature, those kinds of things. We need to be able to expand our material capabilities there. So we're really looking forward to some of the more expansion coming out there. And then post-processing techniques, again, because we're a fluid component manufacturing company.
Exactly.
We're looking at ways we can increase efficiency, increase performance, right?
Mm-hmm.
And get better surface finish on these parts. That will be key. So again, that kind of correlates back to the large component manufacturer. Getting outside of powder bed fusion, maybe D or something like that, we need to look at ways we can increase our abilities around surface finish and those kinds of things. And of course, there's other things you can do within the different capabilities in powder bed fusion, where you have surface and support material in areas that you don't want it. You can then do post-processing techniques like abrasive fluid machining and those kinds of things. We're really excited to, get it in the ground floor here a little bit. I know AM has been expanding a lot, especially in the last 2 years, and our customers are really pushing us now. So in that regard, we are also really looking forward to seeing some advances in these types of areas.
Yes. Thank you, Michael. So next, I wanted to ask Manoj sir. So today I have invited Manoj sir not just for understanding about the AM as a user and as a powder manufacturer. Also, I see him trying to graph things in comparison to the MEM technology, how people were skeptical about the MEM technology back then when they started up, and how it has been getting adopted ever since. So, Manoj sir, how do you see a parallel coming with the AM? Because you might have been seeing the trend coming along of additive manufacturing as it was utilized in the MEM technology itself. Hello.
Yeah, so I would say it took us a while to really disseminate information about metal injection molding. I mean, like I said, that we started in the year 1997, but then metal injection molding has been around since the 80s, I would say, right?
Yes.
So more so, even today, when I go out into the market, I would at least come across 5 out of 10 customers who are hearing about MIM for the first time.
Mhm.
And about 20 years back, probably this number was 9 out of 10.
Mhm.
So this kind of experience with MIM still enables it to remain as an emerging technology. To draw an analogy with additive manufacturing, what I would say is that additive manufacturing probably has been able to catch up faster than MIM, for the simple reason is, I think, more talk about the technology, more media attention. I think using the social media or using all the other probably platforms, details about this technology has been made available to people more. So I would say the adaptability of this technology probably is a shade faster than MIM technology.
Sure. Sir, how are you seeing like as a powder manufacturer also for additive manufacturing? How are you seeing the business trending, and how are you seeing like there have been questions like for a customer like us also for you is like how do you draw a line between an imported powder which comes either from the western part of the world and which is an indigenized, and we have been trying to promote indigenized because it closes that kind of a chain. So do you see any kind of certification giving it more value to it, or any kind of engagement, or any kind of move forward in that front?
Yeah, I would say that's a very good point, Ankit. I think the more important for us is you brought out a good point of certification. So on the certification point, I would say our powders are already certified for its physical and chemical properties as per the ISO standards, right?
Exactly.
But then more so in additive, we depend on our customers to establish the mechanical properties on the printed coupons and so on. And I would like to take this opportunity to thank Objectify and you in particular, Ankit, for supporting us on qualifying on many of those print parameters, developing those print parameters with our powders, because we do realize it definitely gives you a good edge against your competition or against other processes. But I think as a powder manufacturer, it definitely gives us more confidence on what we have been doing and probably helps us accelerate our development process. I
Exactly.
would just like to give an example for 316, for instance, SS316 that we have been developing. There is a customer who came to us saying that he wanted a little niobium and titanium in that, in the 316 powder. And it was not so difficult for us as long as he's promising us that he would print some test coupons with our materials and then give us a feedback as to what does he feel. Because restricting ourselves just to compliance with the physical and I would say chemical properties as per ISO, I don't think that's the rule of the game as far as additive is concerned. More important is the establishment of mechanical properties, which you can get to know only after printing those coupons.
So mostly you're talking about the confidence of the user, the confidence of the end customer who's trying to use it.
Yes. Not only that, I think the adaptability, for instance, you have a very diverse range of components when you print them, right? So through the printing of coupons, probably you are able to establish the parameters which will get you the required mechanical properties and so on and so forth. So that goes a long way in getting confidence to the user that yes, this powder is definitely going to help me use on this machine and get me all the right properties that I require.
Sure, sir. Mr. Tomaso, I just wanted to ask, what is the ask from an oil and gas customers on the end used surface finishes, end used level of expertise as compared to other technologies. Whenever I go to a customer, I get these kind of questions asked: can you match something surface toughness like these or something like that? But I come to them and say that if you're ready to invest into something like this, then we are. So how do you answer that commercial versus the technical aspect, Mr. Tomaso?
Well, of course, some of the complex geometries of the oil and gas application pose challenges, both from a technical standpoint and, of course, also from a cost and then commercial standpoint. Basically, we are trying to really help the customer getting rid of the most painful aspect of additive. Among them, support removal is definitely a problem. I've seen some nice impeller in your presentation, guys. We are working quite a lot with this kind of application, and often support removal are really placed in areas which are hardly, if not totally unreachable by conventional tooling. And that's for sure one of the area where the freedom of design of additive crashes against the post-processing, what we call post-processing barriers. And right, in this case, thanks for coming back on the slide, we are talking about TM particularly, but I would say also TM combined with AFM, because AFM, possibly some of you knows for sure, my colleague here on the panel knows it, is one of the technologies suited for cleaning and polishing of internal complex shapes, and of course is a very good fit combined with TM, because we are basically helping customer removing the supports and then optimizing the surface, which as one of the colleagues mentioned, improves at the end of the day, improves the performance of the part, and particularly of the flow of gas or of liquid. So hopefully I replied to the question.
Yes. So how do you see like the engagers, like Objectify as a bureau? We get different kind of parts, we get different kind of budgets, we get different kind of materials to handle with. So similarly, I think you also have that kind of a challenge of handling different materials, different shapes, different sizes, and different kind of, let's say, quantities. So how do you handle those kind of activities, let's say from an oil and gas customers also?
Well, for sure, these, especially talking about quantities for extrude on, has been overall quite a challenge to cope with the needs of additive, because our technology basically develop in environment of high volume, such as automotive, and for sure coping and dealing with very low volume quantities posed some challenges, and that's why basically we dedicated then a business unit to this fast growing market. Overall, of course, the high mix variability of additive is reflected in sizes, material. I would say that so far, thanks to, because basically extrude on adapted a pretty well-established portfolio of equipment and technologies. So we can cover pretty much the whole spectrum, I would say, of additive application, from low and small parts arriving in low volume up to bigger parts. Well, in this case, usually, of course, bigger part come in low volume as well, but we can accommodate growing volume as well. Talking about materials, well, TEM has a limitation which belongs to the physics of the process itself. despite its attractiveness, it works pretty well, I would say very well with stainless steel and nickel-based alloy. Unfortunately, titanium is a too reactive material, so cannot be treated with this kind of approach. On the opposite side, AFM is an abrasive pressurized technology. So according to the kind of abrasive and media that we use, we cover, in this case, really the full spectrum of AM application, spanning from every kind of plastic where the need is there, up to titanium and carbides material for AM.
Yes.
Cool Pulse, I would say, is in between, is an anodic dissolution technology. So it needs a magnetic field and current to flow between parts and the tool. So basically, we treat mainly metal material.
Mm-hmm.
However, we can build a cathode in plastic that are then plated for results which are, I would say, high level, even with very low volume parts.
Mm-hmm. Sure. So, Mr. Moy, I also wanted to ask you, like, how Siemens, because they have such a big fleet, and from steam to gas to high pressure to now you have acquired Rolls-Royce the fleet of turbines. So how do you identify key components? How are you like working with the legacy components or the MROs, or how are you convincing your end customers for something like additive?
Yeah, I think the good thing is we are OEM for our equipment. So when we implement new technology, that's the given that we stand by our product and stand by the liability and risks involved. So at least for the newer machines, we always show performance improvements through additive, both from a lightweight tonnage perspective when we go offshore platforms. But I think for the MRO side is where we are also trying to recapture some lost ground. There's a huge fleet of gas turbines out there, the Avons and the fiber ones that are already especially in India.
Yes.
They were trying to sort of claw back all the improvements there using additive. One of the things that we're struggling with is because it's a legacy fleet. A lot of the old drawings don't exist, and all of those are in 2D paper drawings. So we need to do the conversion. We need to do reverse engineering, and most importantly, try to find the fleet that's out there. So the MRO side, the legacy fleet that we're trying to target, we struggle a bit because the commercial value of improvements is not there. You know, these equipments have been running for 60 years, so most customers are looking for short fixes. It's a workhorse, if you will, the Avons. So giving them any additional AM improvements, the cost value isn't there. Even though they want to run, they can run at least another 20 years more.
So how do you like, let's say if you want to productionize, let's say in your Finspång facility or your Berlin facility or the Worcester, the Material Solutions facility. So how do you like tackle, because Siemens is not just a part manufacturing or a OEM, they're also on the software side. They work a lot on the software side. And as we are end users, so we also understand how an important role softwares also play. So that batch for utilizing in different facilities around the globe, how do you manage that through your software?
Yeah, so we have what you have mentioned before, one of the panelists has mentioned before, digital inventory, where each of the locations are sort of focused on a particular range of equipment. And once that equipment designed for AM has been qualified, it's put on this global database, inventory database. So the various sites are able to replicate the same spare parts that we have, and there's a lot of sharing of information. And like you mentioned, we also do software.
Yes.
So whatever data that we collect from our production sites in Finspång and the Material Solutions, all this gets fed back into software, and we want to enhance the capability of the software, like I mentioned before, so that it simplifies the work for designers. You know, there's a lot of key buttons within NX that's about compensation for lean, for powder bed prints. So we want to simplify the process. We want to make it accessible. We want to make it portable, so we can print closest to customer. So we manage this digital inventory through the different sites, even though the focus is on different parts.
Exactly. So it is something like on project to project basis, and it is on component to component basis that decision making and certification is done at Siemens.
Yes, yes. I think we would like to find more partners. I think, and as Satri mentioned quite succinctly, certification is important. So wherever you go, you will find a certified services bureau that will be qualified to print that part for aerospace or oil and gas. Exactly. And without that certification, you can't do that. I can't open 4, 5, 6, 7, 8 different material solutions around the world. We will eventually depend on outfits like yourself, Objectify, to get certified and qualified by Siemens, so that you are able and you'll be certified to print our stuff on our behalf.
So the only case I just wanted to ask is like what I've understood from an aerospace to an oil and gas or a power sector, it is like power requires a lot of time and the speeds are quite low. And in aerospace, it is other way around. The time of utilization is quite low, but it is required to run really fast. So how do you work on the properties? How is that standardization, qualification, and certification done at Siemens?
Well, that's a tough one. Different industries have different requirements, as you mentioned, quite succinctly. I think we still design on the same principles and performance. With our aero derivatives that we acquired from Rolls-Royce, I think we still adopt the same ethos. We try to apply the same design boundaries to our larger gas turbines. Not always directly applicable, but we generally, as I said, we try to maintain different focuses at different sites on different ranges of equipment. So the team in Sweden, in Finspång, focuses on the mid-range and the aero derivatives. So they're very strong in that small space for the simple cycle, if you will, gas turbines like Trent and the RB211s, whereas the larger gas turbines, the 3000s and 4000s Fs, are all done in the US. So there is a big gap between the two, but we try to share technologies. It's not so transferable, I would say, as you scale up. And obviously the different industries, power, gas versus oil and gas, is very different in their requirements.
Sure. Thank you, Mr. Moy. The next question will be with Dr. Shastri. So the most important thing what DNV and Additive is doing is like trying to co-own the risk of certain certifications for certain components for certain organization as an end use. So how does that risk mitigation, that risk handling, DNV do it for their end customers?
Okay, so actually, risk mitigation is our DNA. So since 1864, 156 years, actually, DNVGL is always doing this risk mitigation by developing methods that actually filter, like we work like a filter, So whatever, like you take a dirty water and filter it. So this is how we do this. And this risk management is done in different ways. For example, one is by identifying and designating the parts certification requirements. So we have a lot of design rules. For example, for maritime, we have what we call as a prescriptive rules, where the design rules specifically tells, for example, in maritime, you have 1 million parts. So all these parts are classified, which part requires what level of certificate. And most of the certification levels are only three levels. So highly critical, and medium critical and low critical. So highly critical means when this one fails, what is the impact of the failure, and also the probability of failure. So using this risk matrix, we stabilized already the most of the end user components. So if we know the components usage and usage, we already know how deep we should go in implementing, looking at the finer details. So that is one methodology. Second one, for example, in oil and gas is much faster movement than technologically advanced than maritime, where more deeper waters are exchanged, more harsh environments, where they always come with new materials, new technologies. So we have a methodology called technology qualification. Technology qualification is a systematic way of making finding out what is known and what is unknown, and how do we normalize this unknown to known. So sometimes the technology qualification can be run fast in 2-3 months. Sometimes we have seen like some of the drilling heads, etc., takes 1 year or so. So I can say that either by identifying the certification needs in forefront, or by doing the technology qualification. And as part of the technology qualification, we have a failure method analysis, for FMICA analysis, and we use that analysis and see that what kind of failure modes that would be possible, and what additive manufacturing is bringing new failure modes. So that is why we are integrating this into this technology qualification, and helping our customers to mitigate the risk. So always you never find, a lot of customers ask is, if the NVGL certifies, can you tell that this part will never fail? We say no, it is not in our hands entirely. So but we can say that we can bring the certainty. At least we can tell at a certainty that how and when it can fail, or if it fails in a controlled ways, so that there won't be serious safety issues or safety accidents, or there won't be serious operational losses.
Economic
That
losses.
is the meaning of certification and risk management. Yeah.
Sure, sir. Sure, sir. So Michael, I also wanted to ask, when you have a very big funnel of identifying and customers requesting for faster components, and there are certain challenges about the technology. First is surface finish, the second is materials, the third is the process itself. So how do you answer your customers about those, and how do you convince them?
That's a very good question, and I think it's a broad one right now for us. And what we're working to do is to build what we're calling a technology application matrix, so that our internal engineers can smartly choose the right technology and the right material to handle that. And it's an ongoing effort, and we're working with our partner customers these items to identify some of the most critical points that they have issues with, so that we can, provide a solution around 3D printing, if it makes sense, right?
Yes. So what are the biggest challenge as a manager of research and development at Flowserve you have faced with Additive? Like, what are the key questions you have asked it never answered you?
A lot of them recently have been, I would say, specifically around I think material development. So again, when it comes back to a lot of the products that we make, we have to serve a lot of different applications. Pumps have to produce and move fluid, all kinds of fluids you can imagine, corrosive, high temperature, all those kinds of things. So really, I would say that right now we're really, I would say, focused.
So also, I'll again move to Manoj sir for a question about comparing the MIM, the key answer right now after the COVID. Actually, from the past webinar itself, I have decided, like, the word of the coronavirus or the COVID, I'll use at the very end. So I just wanted to ask, like, as supply chain disruption which can be done after like this COVID-19 hitting with your customers also, everybody's getting affected. So do you see there is a business proposition, a new business proposition for additive coming in the picture?
Well, thanks for that question, Ankit. But I don't see any specific change in lieu of COVID on this particular point, because this has been a question to us, probably hitting almost in every meetings, in every webinars and seminars that we have been doing. What I would like to highlight here for the benefit of all the attendees is that MIM has a very specific niche target market to address as against the additive, right? So when we are talking about producing tens of thousands of parts and millions of parts, I think that's where MIM comes in. But if the design is not firmed up, and if the customer just wants to avoid the investment of tool or mold and get just the form, fit, and function of the part to validate the design or to verify whether they can go for mass production with the design, I think that's where additive is being used, right? So that's the main difference, I would say, which is there. And with respect to COVID, I don't see any great effect or anything change that has occurred between comparison of these two processes for the addressable market.
So you see there is a different process chain and there is a different set of utilization of different technologies.
Yes.
Okay. So as a powder manufacturer, what kind of key attributes are you looking at? Because most of the powder manufacturers, what we have encountered, are from the gas supply side, and Indumim is one of the actually user also of their manufactured powders, and they are also supplier of for the AM technology also. So how do you see the agencies getting closer to the powder manufacturer? And as Michael said, the key challenge is selecting the right material and of the availability of the material. So how should we answer something like that?
Yeah, so I think it's an answer not just to you but also to Michael, because we have been in contact with Flowserve here in Bangalore, in Whitefield, in the past, with respect to exploring some of their investment casting as well as MIM requirements. So what we are doing, especially for the power segment, I mean, I would encompass thermal power, gas and oil and gas, and all these sectors. What we are doing is we are in discussion with various customers like you for developing specialty powders like Nymonic 90, Astalloy C26, 276, Vaspalloy, Mar-M. So these are all the new grade powders where availability of powders directly from some of the leading global manufacturers has not been very common, or probably it has been at a price which is not acceptable to you. So we are in the process of developing these kind of powders.
Sure.
So that's the step which we have taken. I'm sure you are probably already partnering with us on development of many such things.
Exactly.
And little while earlier, when I told you of answering your other question, we are also open to making tailor-made powders. I mean, if Flowserve Michael has any specific requirement where he wants you to make any components out of a special powder that he wants us to make, we are always open.
Sure, sir. So Michael, most of the components which we do, we work with Indumim a lot, and we work on the different grades of the powder itself. So on the finishing side, and as we are running short of time also now, so on the finishing side, how do you see the cost, the quality, and the time being a key factor in the post-processing side of the things also? Tommaso, can you help me with the answer with that?
Sure. Basically, you mentioned one of the three key pain, I would say, for additive, particularly looking at the serialization of additive manufacturing. Cost of post-processing, as I mentioned before, particularly when we look at the complex shape that additive is able to produce, pose definitely some challenges. That being said, I think this really belongs to the kind of application and particularly also to the design effort, which is somehow poor in the project at the beginning, also looking at post-processing. With this regard, we have some example, without disclosing, of course, name of company we are working with, but we do have some example which belong to the automotive industry, where there is currently a huge effort to drive down the cost of additive and basically make it a good fit for also some of the automotive components. And with this regard, despite the cost still remain a challenge, I see, I would say, a quite strong driver to lower it, and I'm pretty sure that this will happen in the coming months and in the coming years.
Mm-hmm.
From a time-wise, well, definitely additive is a fast and agile technology, so needs fast and agile response. This is basically why we do use additive ourselves to cope with this kind of need. Most of the tooling we do use in our hand finishing processes are currently 3D printed in-house.
Oh,
so
great.
we do have metal 3D printing capacity, and thanks to this, we somehow accommodate the need for short response.
Mm-hmm. So,
please, sorry, go ahead.
yes, yes. So what I'm trying to understand now from the post-processing side is like, is it a decision maker for the end customer? Because as you have been mentioning about the aerospace, the automotive, and the oil and gas we are talking about today, and I also go to my customers and we also talk about some things, and they come back to me like, if we are not able to print it at that certain RA value, it is not good enough for us. But people like you can answer those questions better of post processing, finishing the component itself. So do you see that kind of a synergy with the key stakeholders? Do you see there is a value for working with companies like Objectify or any other service bureau in your region, closer for your end customers?
Well, definitely the approach with additive. Can you hear me? I have a
yes, yes,
okay.
yes.
I had a message of like weak line connection. Well, definitely the partnering with the stakeholder, in this case the customer, but I would not only mention the customer. I tend to have a wide open approach to all the key stakeholder within the industry, especially when approaching challenging projects. We know that right now additive requires a sort of development activity, research activity, which somehow is built through a more close relationship with the customer. Mentioning again cost, this is we know that so far at least additive is a rough technology in terms of surfaces. It's also true that the cost of additive belongs at least today from its greatest part to the equipment, the cost of the equipment usage, which is related to the speed, the building speed of the part. Mm-hmm. And as we know, the faster you go, the less you will pay the part basically, but the surface will be very rough. And I think here we play a key role, which is not yet fully understood, of course, from the main players, but not speaking about a wider audience. So I think we really play a key role together with other stakeholders in optimizing what we call the build and finishing strategies, which are actually have to be seen as a combination of process which in the end delivers an end product with some characteristic, including cost. And in acting in between these two strategies, I think there is quite a lot of room to work again with key stakeholder to let AM being even more competitive than it is today.
Sure. So we have Deepa ma'am joining us. She has a question she wanted to ask. Deepa ma'am, are you there? Hello. She was earlier working with General Electric, and she wanted to ask some direct question right now. Deepa ma'am, can you go ahead?
Yeah, sure. Thanks. Thanks for a very interesting panel to all the panelists. It's been a very enjoyable session listening to everybody. So first of all, I think I posed the questions and I thank Mr. Kabre and Dr. Shastri for answering it. So question, I'll start with the cold spray that he mentioned. We've been hearing, of course, everybody's focusing on powder and powders. He mentioned about cold spray. I just wanted to, he mentioned some applications were implemented in a couple of oil and gas sectors. So I just wanted to know a very specific technical point of what his experience has been with hard metals in the cold spray technologies. Because I'm very familiar with Speed 3D and been working in the cold spray for the last 10 years. So I want to know his experience on implementing it for nickel and steels, especially using nitrogen as a process gas.
Yeah, so thank you again. As I answered, we see cold spray could be used mainly for two purposes. Well, the first main purpose is as a repair methodology to restore some of the worn out components. For example, for wear resistance applications. This is what we have seen in very hard metals that were coated to some of the submarine exhaust ports, etc. And also we have seen in the nuclear power plants. So they wanted certain lifetime. Of course, there are certain problems as you mentioned about fatigue and etc. But these were, unfortunately, what happens is when significant energy or time and research is input here, so those companies convert that into IP, and it is very difficult for you to see. But we have seen very high-tech applications when developed with nickel alloys and steels. And these are the applications as to restore, either for corrosion resistance or wear resistance applications. That is for the repair. Or, for example, now I see cold spray, for example, they're trying to use to produce some of the titanium kind of alloys. That titanium is quite expensive, but now some of the Australian companies, for example, working with us, has developed to cut down the cost, and they can directly use the granules coming from the ore, and they transform it into a finished product where they can bring the titanium alloys to the life. So it means then you can get quite a solid product that can sustain corrosion environment or a severe harsh environments. And the repair applications, we have seen numerous repair applications.
Okay, thank you. I was more referring, yes, I'm quite familiar with softer metals, but maybe we can take it offline. I don't want to hog time here, but I was more curious about, nickel and stuff, where which didn't really quite work out well. So I'll ask Ankit for your email and take it up. And I think the second question I had was, and I thank Mr. Manoj for responding promptly. I was pleased to see that because we had started it with Indomim in 2018. There were some difficulties in the chemistry, the very first lot for AM at least. So it's good to see that. The question I have is a follow-up question, since I'm able to speak to you, is, batch-wise, I'm not sure if the quantities that came out, in terms of yield was, at least at that time, 2 years ago when we started this exercise with Indomim, it was not quite producing the yield necessary for AIM because it's the last in the sieve of gas atomization. So has that improved now with the advanced sieving technologies?
Yeah, first of all, thank you very much, Ms. Deepa. I think there are very few customers who keep track of suppliers like us in spite of changing organizations. So first of all, thank you very much for that. And I think DMLS definitely is one of the very important customers to us with whom we are working very closely these days. And yes, definitely there has been a lot of change and evolution. It took us some time. Our manufacturing and operations and engineering team has done a wonderful job of enhancing the yields and working on proprietary sieve technology, owing to which the yield levels definitely have gone up. This also enables us to remain competitive in this market. As you know, we are the only company in the country doing these kind of powders, and if we are not able to really qualify our powders with respect to both properties as well as price as against the international competition, who are definitely manufacturing far higher tonnage than us, it may be difficult for us to sustain. So on both questions, yes, the yield as well as the the quality has certainly improved, consistency has certainly improved, and we have been able to give a good batch-to-batch consistency. And I think who could be better than Ankit to ask this question?
Well, thank you, and congratulations. Very happy to hear that.
Thank you very much.
Yeah, Ankit, if you may, I have one more question, and then you can mute me to the colleagues in Extrude Home. Can I ask, or would you prefer that I document it in the Q&A and wait my turn?
I'd be happy to reply, of course.
Okay, well, Ankit has to tell whether I can ask you whether I should await my turn in the list of questions. So I'll allow him to be the moderator.
Ma'am, you can go ahead. You can ask the question.
Okay, I will also document it after I ask it. I saw the very interesting finishing operation. So, I think there was some connectivity loss, so I couldn't quite follow the TEM and the AFM. So I'm sorry if you have to repeat it to me, but is it AFM as an atomic force microscope, or
abrasive
does it
flow
have
machining? Abrasive flow machining.
Abrasive flow, okay. And what is, I'm sorry, what is TEM?
That is thermal deburring.
Okay. I'll take your contact details and perhaps offline and ask a few questions.
Sure.
Thanks, Ankit. Thanks a lot.
And thank you, ma'am. Thank you so much. So, Mr. Moy, we would like to because we have already ran out of time. So, Mr. Moy, we can start with the closing remarks and closing thoughts of the industry about the technology, about how we are placed currently, because most of the world cannot foresee what is going to happen, because nobody in our generation has experienced something like this of the scale. Yes, Mr. Moy, can you
I think I'm very pleasantly optimistic about the future with regards to 3D printing and additive manufacturing as a whole. I think this whole current situation has really pushed a lot of companies to rethink their supply chain strategies going forward. With a lot of countries being locked down, especially in China in this case, a lot of my customers are struggling to produce stuff, and they can't get access to supply and spare parts. So a lot of the community, at least in my region in ASEAN, have been reaching out to the AM community within Siemens and our partners. So we see that this is stronger push and revisiting and the adoption of additive manufacturing as a third source of disruption or supply chain going forward. So I'm pleasantly optimistic. that once we get through this, things will move more acceleratedly towards adopting 3D printing.
Sure, sure. Thank you, Mr. Moyo. Thank you for joining.
Exactly. Cheers.
Yes, cheers. Then the closing line, if I can get from Dr. Shastri.
Yeah, thank you very much. Yeah, in general, first, do you want me to comment on what is the future or?
Yes, yes. Like a thought for.
Okay, yeah. So yeah, just I can even not only my opinion or thoughts, but also we can see the already we have been experiencing this for almost more than 100 days in Singapore, and I have seen actually a clear change of mind with many of our customers are those people we are interacting. Actually, they see there is a bright future for additive manufacturing, and they see that this is one of the alternative routes you must you must secure and keep your to keep alive your supply chain. So yes, so I have a very good impression that despite this COVID, COVID could have actually stopped the funding flow to some extent, but the spirit is very high and the activity level is very high. And I see that it would be doubling and tripling in the coming months because everybody started thinking why this is important. So earlier I used to spend 2 hours to tell somebody some of the CEOs of big shipping companies, but now I need only 3 minutes. Actually, they are approaching me. So
So
yeah, that's
someone's gain someone's problem, right?
exactly. So I see that there is a good future, and I think so. Actually, luckily, before COVID, industry has grown to such a level that it can offer concrete products and complex products. So that is why many people started trusting that, and I see this will be a certain future for one of the it will stay as one of the alternative routes to some of the parts or many parts. Yes.
Sure, Mr. Dr. Shastri. Thank you so much for joining, sir. It was a pleasure hosting you. I'll just come back after talking to everyone. So I want to talk to Michael and Kaushik, sir. I've not spoken much with Kaushik, sir, also, but he has been also one of the connect with Objectify from ProServe. And I just wanted a closing comment from both of you about the thought, about the move forward, about where we stand and where should we look.
Sure, yeah. Mike, I'll go after yours. Okay.
Sorry?
Sure. So, yeah, I would first of all, I would like to really thank you, Ankil, and Objectify for this on this call. And I would like to just very simply just echo what Mr. Moe and Dr. Sastry said, that I 100% agree that after what we've seen recently with the ongoing situation around the world, that even with all of that, we still find that even our customers are very dedicated to 3D printing and continuing this initiative around advancing their technology and supply chain efforts with this. So we're very interested and dedicated to continuing our efforts around this. So I'll leave it to Kaushik to provide his final thoughts too. Thank you.
Yeah, sure. Mike. Thanks, Ankit. Yeah, so basically, in terms of challenges, we have been reviewing this technology from Flozo since 2000. So, the challenges what we faced that time, and we are seeing a lot of developments going around in the ecosystem that we are seeing today, from software to OEM parameters and machine settings and qualification process, processing techniques. So I think we would like to move out from R&D scale of R&D to a bigger commercialization scale, where we want to utilize 3D printed parts in terms of commercializing to market. So that's where you address the key challenges in terms of part size, material choices, and post processing. So this panel brought us a good context. So maybe from here we can proceed further individually, and see how we can bring more successful case studies, and parts in near future.
Thank you, Kaushik, and thank you, Ms. Michael. Thank you for joining us. Can I talk to Manoj sir? Can I get your thoughts as we are getting stronger and as we are trying to understand the technology better, and as we have been engaging as a supplier and a customer kind of relationship? How do you see that evolving better for
Sure,
us?
sure, Ankit. So first of all, thank you very much for inviting me for this discussion. I think it was a great session. I really enjoyed it and got to learn a lot from all of you. I think I would agree 100% with all the other panelists in terms of the future outlook. And I would say specific to India, I think it is very well progressing as far as the additive manufacturing scope is concerned. And if I come to specifically metal printing, I think it is certainly growing well in automotive, tool industry, medical industries, and a bit in power sector as well. So in my mind, this can definitely be a very good tool for making prototypes and smaller batch quantities. It's still yet to adapt for mass production, as I also saw one of the question in the chat box or question box, and I have answered that. So when we talk about smaller quantities, say up to a few hundred pieces, I think this is the technology to continue to grow. I mean, the easiest way I can share with you is that as a powder manufacturer, our journey over the last 2 years has been really good. Thanks to customers like you, our powder sales has gone up 10 times. So between the last 2 years, so for additive. So I think that itself is a sufficient proof of the fact how the market is growing. So I don't think COVID has in any way disrupted the sales for people like you. So you can continue to grow with us as a supplier as well as a customer. Thank you.
Thank you so much, sir. So the last closing line I want to take from Mr. Tomaso and Mr. Chandan. Mr. Chandan joined us a bit late, so Mr. Tomaso, do you want to go ahead with answering this?
Well, I think the other colleague panelists pretty much cover also what is my thinking. I would add just that for sure COVID created an unprecedented situation for the worldwide economy. I still believe that this is somehow destinate. I mean, the forecast from my angle is that it will recover, while on the other side, this emergency, and we had many examples starting from my country, Italy and Europe, but all over the world, where the reaction of the additive manufacturing industry, thanks to the agility of its supply chain, was somehow key in supplying goods that were in shortage. And this is something I feel will somehow stick overall in the mind of people, and somehow will help also changing a little bit the mentality. We've mentioned during this very interesting panel that there is some resistance yet from customers, from people that are skeptical, and all that goes and works in the direction of evangelize people in the community, I think is pretty good. And so I see also some positive fallback from this side. Of course, different topic from the aerospace angle. This is a more complex topic which would possibly require one panel session by itself. But still, I'm absolutely positive. And by the way, let me end by thanking you for inviting me, and everyone for the pleasant and interesting discussion.
Thank you so much. Thank you everyone for joining. Hello.
Mr. Ankit?
Yes.
Chandan here. Sorry.
Yes, sir. Yes. Tell me.
Yeah, I would like to thank the Objectify for giving us the opportunity. I think now the responsibility is between both of us to get the additive segment into the mainstream industries, as in 3D services, this thing, and as in post-processing. The responsibility lies with both of us, to getting the awareness, which I think still in the nascent stage in the Indian industry segment per se. So
Sure.
I think it's time that we need to work together.
Sure, Mr. Chandan. Thank you for joining us. Thank
Thank
you,
you.
everyone. It was a great pleasure to host good friends, good partners, good collaborators with the innovators in their mind. So it was a great pleasure. It was a dream to host a panel like this. Actually, we wanted to in person, but I think for certain point, these webinars are doing really good for us also. And we really wanted to impart our knowledge. We really wanted you to talk to a lot of audience, because what we have been seeing that our audience has been a mix of academics and a mix of students to mix of users from the industry. So everybody needs knowledge, and this was the right way to impart that knowledge to them. And it was an exciting webinar to host, and I'm really happy. I'm really proud that we are in great connection, and we will be fighting strong against this uh, upward wind. And let us move further with the same. Thank you, everyone. Thank you, everyone, for joining, and it was a great pleasure. Thank you.
Thank you very much, Ankit. Thank you.
Thank you. Thank you.
Objectify entire team. Thank you very much.
Thank you, sir.
Thank you, Ankit and team Rahul. And yeah, it was very professionally managed. Thank you. Bye.
Thank you.
Thanks,
Thank you, sir.
everyone.
Thank you very much.
Panelists
Yes,
as well
thanks.
as audience. Yeah.
Yes.
We will be sending the bundle package of the feedback and how the event was appreciated. So we will be sending a report out of that, as well as the report will have a link for the recording. So you will not miss the session. Yeah.
Mhm. All right. Thank you. Thank you so much. Bye bye. See you soon.
Thank you.
Yes. Bye bye.
Thank you everyone for joining in. Thank you for the panelists, Mr. Sastri, Mr. Benjamin Moy, Michael Zimmerman, Kaushik Ashokan, Manoj Kabre, Tomasco, Chandan, and obviously our own director, Mr. Ankit Sahu. Also, a special thanks to Deepa ma'am for joining us. I would like to thank Tagma and Tagma India, our associate partner, as well as Manufacturing Tech Update, for partnering up with us. Do follow us on social media so that we can keep you updated regarding all the future upcomings from Objectify Technologies. Again, thank you everyone for joining in. Stay safe and stay home. Bye-bye.